weekend promises to be exciting as we have 12 female researchers in science, technology, engineering, mathematics, and medicine talking about the exciting research they're doing in their labs and universities, from medications to soil worms, from diabetes to computers. It promises to be an exciting weekend of science. I'm especially looking forward to interacting with the speakers and asking them questions about their research.
Thank you, Tochi, for that lovely introduction, and welcome everyone once again to our Soapbox Science Lagos November 2020 event. This is going to be exciting, and I hope you're excited. So now we're going to hear from our first set of 6 speakers. First of all, we have Dr. Khadija Adebisi Abdusalam, and she'll be talking to us about the brain and the computer, the digital life we live in. Enjoy.
Good everyone, welcome to my Soapbox Science. My name is Khadija Abdusalam from the Department of Electrical and Electronics Engineering, University of Lagos. And today I want to talk to you about the computer and the brain. Computer is an electronic device that accepts inputs, processes it, and gives output in required form. And it exists in various forms today. For example, our smartphone that we all carry about, our smart device, these are all forms of computer. The laptop, the traditional computer we are used to is still a computer. The one that has a television-like output display, the box, the CPU, our keyboard, and our mouse. Also, computer exists in form of doors. The door that opened for you the last time you visited the big supermarket near your house is a form of computer, or when you visited a big hotel, is a form of computer. Then the brain. The brain is the command center of the whole man, of the man. It determines what instruction, how to do it, and when to do it. And the brain stores information. The brain stores information, and it improves through learning. And through learning, man becomes more intelligent. When man becomes more intelligent, he is able to create tools to assist his existence. And through the intelligence of man, man created the computer. And they created the computer and also gave the computer its own man-made brain. The computer is like any other tool that has assisted man to increase production of goods and services. And we know the many things computer has done to man. When computers are connected together, it has facilitated communication through the world. It has helped improve banking transaction through the POS. We know during the COVID-19 stay at home, we use the computer to continue to work, and we are still using it to work. Our children were still attending school while staying at home through the use of the computer. And we still continue to use the computer. The computer has helped man to make life better in different ways. And we also know through the computer, we are able to keep in touch with our business partners, our friends and family throughout the world. Like I said before, man has brain, the computer also has its man-made brain. And because man has seen the many benefits of computer, we want to make the computer a bit intelligent by training it, such that we teach the computer some inputs and we tell the computer the outcome through a special field of computer science called artificial intelligence. So that in future, when the computer sees similar information, it will be able to make decisions to assist man in production of goods and services. And in this light, I would like to draw some similarity between the human brain and the computer brain. The man intelligence increased by learning and relearning. Also, the intelligence of computer is also expected to increase by learning. We are expected to teach it. And also, the man makes decisions based on what he has learned, the knowledge he has acquired from what he has learned. The computer is also expected to make some decisions based on what it has also learned. Like in all of our research work, We trained our computer model to be able to determine the amount of electricity that will be required in a given area. For example, in a residential estate. We trained our computer with the number of people that are living there, the type of household appliances they are using, the weather, and the economic ability of the people living there. And we use these four as the input, and we use their present consumption as the output. And we trained our computer model to be able to recognize that pattern, that if 10 people are living in a place, they have iron, they have microwave, they have electric cooker, and the weather is hot at so temperature, and they are middle income people, we expect them to use this amount of electricity, so that when we use that similar model in a similar area, it can give us an idea of the amount of electricity that will be required, so that government can plan for electricity generation, or the investors in the electricity industry can plan their investments. In another of our work, we use another computer model to determine people that have meningitis. We trained our computer model with the picture of the blood sample of people that already have the sicknesses. So we trained it to recognize the pattern, so that when we present our computer model with another blood sample, it's able to tell us if this person has the sickness or not. I'm also aware of some of my colleagues that have used computer model data to recognize a person by the way the person laughs. This one is applicable in security industry. So we are able to identify somebody by the way the person laughs. Other application of artificial intelligence in everyday life that we are used to is the robots. The robot is used as security guards. They are used in industrial plant to lift heavy objects. They are used in assembly plant to assemble cars, trains, aeroplane, ships, and other heavy equipment. They are also used to go to difficult terrains, maybe where there's too much ice, where human being cannot stay, or where there's water in the deep ocean. They are used for exploration in those difficult terrains. Also, another application of artificial intelligence in everyday life is the intelligent traffic lights. This intelligent traffic light only turns green if there are cars available to pass and the outward lane is free. These are made possible because the computer has been trained to have some intelligence, to make some decisions like man. And now, I've just told you what the computer is. Now, I want to tell you what the computer of the future will do as we continue to train the computer. The computer of the future is expected to help us to drive our cars. So we are expecting self-driving cars. With the computer of the future, the pilots will be replaced by the computer. So we'll be traveling with self-flying aeroplanes. With the computer of the future, human beings will be able to wear small computer that will be able to monitor our location. That one will be like anti-kidnapping device. And also, we'll be able to wear some small computer that will be able to take some medical sign, health signals that will assist our doctors to make diagnosis for us. So, in view of this, I want to encourage us, because the computer of the future is going to be exciting. It's going to make life easy for man. And I just don't want us to be users. I want to encourage us to come on board, to be part of the people that will make this thing happen. Because the brain of the computer of the future, we need to be set by the brain of man. So I want to encourage us to take career in computer sciences, because it is going to be prominent in the future. Thank you for listening.
Thank you, Dr. Abdul Salam, for that interesting talk on the brain and the computer. Remember, everyone who's watching would really love to have your questions being sent in. Just look down in the comments or chat box if you're watching on Facebook, on YouTube, or on Twitter. Whichever one it is, please begin to send your questions in for Dr. Abdul Salam. And now we have Dr. Oluwatoyin Adebola Adeleye, and she will be talking to us about gestational diabetes. Should I be concerned? That's the title of her talk. So enjoy it.
Hi everyone, I'm Dr. Oluwatoyin Adeleye, the Country Account Manager for Merck Pharmaceuticals and Life Sciences Limited for Research Segment, a subsidiary of Merck Group Germany. I'm here to talk to you today about gestational diabetes. Should you be concerned? Yes, you should, whether you're a man or a woman. Now the question would ask us, what's the big deal about gestational diabetes? Or what is gestational diabetes? Well, simply put, gestational diabetes is diabetes during pregnancy. Well, we say gestational diabetes or pregnancy-induced diabetes is any form of diabetes or glucose intolerance first diagnosed during pregnancy. Meaning, it was never diagnosed before pregnancy. Suddenly during pregnancy, this person gets diagnosed with gestational diabetes. Wow, how is that possible? Well, studies have shown that about 5% of women are diagnosed with this condition annually. 10% of women, that's a whole lot. And so you and I should be concerned. Now the question is, what are the symptoms? Well, when you talk about frequent urination, it's a symptom of gestational diabetes. Or you might say, almost every pregnant woman urinates frequently. Why? Usually as pregnancy progresses, frequent urination is a common symptom because of the weight of the baby on the bladder. But when it becomes too frequent, then you need to pay attention. Excessive thirst or excessive hunger is also a symptom of gestational diabetes. Then, during pregnancy, usually between the 24th and 28th week of pregnancy, there's always a test every pregnant woman runs, which we call the oral glucose tolerance test. This oral glucose tolerance test involves you taking the glucose solution, and after some hours, your blood sample is taken and tested. And you'll be told, oh, your blood sugar level is okay. Oh, yours is high. Have you had diabetes before pregnancy? Some will say yes. Then some will say, no, I never had diabetes. Then what's going on now? No, there is nothing to fear. It's probably because there are some underlying factors that you just never noticed or paid attention to. Now, the question is, what puts me at risk? Or you might say, oh, why should I be concerned? Am I at risk? Well, two major factors put women at risk of gestational diabetes. And this could be divided basically into the genetic factors or the environmental factors. Now, you'll be wondering, what are the genetic factors? Well, women will belong to specific ethnic groups or races, such as African women, African American, Hispanic, or Caucasians. Ha! Very prone to gestational diabetes. Well, it could have to do with kind of genes and specific genes that we carry. Now, another factor that puts you at risk of gestational diabetes really has to do with your previous health history. Well, if you previously had cardiovascular disease such as maybe high blood pressure, you could be at risk. This is because this has to do with most of the medications you use. Some of these medications could impair on the effects of insulin. Now you would ask, what has insulin got to do with all of this? Yes, insulin is a particular hormone that our bodies manufacture to help us digest the glucose we take. Well, are you taking fizzy drinks or you take your normal carbs? This insulin takes helps the glucose you take or the carbohydrates you take to help the body to digest this glucose or sugar, as we may call it, so that your body can use it for energy. Now, if you have high blood pressure, you'll be on some specific drugs. These drugs, may not even be high blood pressure, could be some other health conditions that require you to take some specific drugs. These drugs could prevent the insulin from working properly or hinder the production of the insulin, thereby resulting in high blood glucose and your body being able to use up the glucose, so it stays in the bloodstream. Then this woman gets pregnant and she has high blood glucose. She's tested between 24 to 28 weeks and she's seen as being diabetic or has glucose intolerance. It doesn't mean she's been diabetic before, but pregnancy has a way of working on the body and making the body unable to utilize the glucose. Now, or if the woman has previously had a baby that weighed more than 4.5 kg, maybe in her previous pregnancies, she equally runs the risk of having gestational diabetes. That means possibly she's been having it, but it just went undiagnosed. Now, the question I now want to ask is, what other factors? Well, other factors also include your body weight. A woman who weighs more than 4.5 or 45 kg or 55 kg runs the risk of having gestational diabetes. That's because high body weight increases the production of fatty acids or triglycerides, which could impair or affect the production of insulin, or even the insulin could be produced. Most times insulin is produced, but these fatty acids or drugs prevent it from working optimally like it should work. So it does not allow the body to digest the glucose because the insulin must work optimally for the glucose to be absorbed by the cells or by the body. So once the insulin is not working well, the glucose is unable to be used. So it keeps flowing around in the bloodstream. And the individual is detected as having high blood glucose. Now, another condition is age. Age has a way, if you are 25 years and above, you actually run the risk of gestational diabetes. Especially when you are 25 years and above and you are still having children, you run a risk. Why? Because age has a way of affecting insulin production. As you grow older, most times your pancreas produces less insulin. So not in all cases, but in most cases. So if you're still having children at 25 years and above, then you're at risk. And if you've probably your previous pregnancies, you've had a case where we known as polyamylose, whereby this person you have too much amniotic fluid or you produce too much amniotic fluid, then you are equally at risk. Why? Because too much amniotic fluid increases the production of specific hormones, pregnancy hormones. These hormones actually play when it comes to you maybe having hunger, excessive hunger during pregnancy, but when they're in excessive amounts, it prevents the insulin from working optimally, resulting in the body not being able to use up glucose in the blood, now causing high blood glucose. Now, the question I want to find out is, yes, if I have gestational diabetes, how does this affect my baby? Because as women, we care so much about our babies. Yes. Most times when you hear, okay, a woman is pregnant, the first thing people always say is, oh, she's eating for 2, she's eating for 3, she's eating for more. That shows that most times everything you eat as a pregnant woman actually affects your baby. From the nutrients, the food, the minerals, oxygen, everything flows from the woman to the baby through the placenta. So when a pregnant woman has high blood glucose, same thing flows through the placenta to the baby. So now a baby has to contend with the high blood glucose that is flowing to him or her. Now, nature has it that as a baby, once the body of the child detects the high blood glucose, high insulin production is triggered. So now the baby has to produce high levels of insulin to meet up with this high blood glucose, resulting in a baby with a big weight, with a high weight. So you could have babies of 4.5 kg or even more, which we refer to as macrosomia. And in some cases, this high blood glucose could result in maybe the production of triglycerides or fatty acids, even in the mother, that could be passed through the baby. So when this is passed through the baby, could result in something we call diabetic ketoacidosis in the unborn child. which could cause low brain function or even death. This is not to scare us. Most times, the high body weight of the baby could result in the need for cesarean section and could even result in death of the baby or even the mother. And the resulting effect is most times women with gestational diabetes always end up having type 2 diabetes later in future. Why? This has to do with affecting the insulin production, not these hormones, these health factors, this age, everything together affects the hormone production. Either reduces the production or makes it not to perform optimally. So it's not aiding the body to digest glucose. And as a result of that, the woman develops type 2 later in life. Now the question we would ask is, wow, this is scary. Well, not too scary because it can equally be prevented. When you know you're at risk of having gestational diabetes, one, try to get tested early. You could go to a number of molecular diagnostic center clinics around you, get tested for susceptibility to gestational diabetes, or you don't even have to wait till you're 24 or to 48 weeks gone in gestation or pregnancy before you get tested. Then, you also have something we call lifestyle modification. Be involved in exercises, eat lots of vegetables and fruits, and ensure you always see your general practitioner or doctor regularly to let them know, oh, I run the risk of gestational diabetes. This is because a family of mine, if my father or mother has had diabetes before, or oh, okay, I belong to this ethnic group. I'm this age. I take this drug. I've been taking this drug before pregnancy. You already know the risk factors. So once you know that, you discuss that with your doctors, and they guide you. It's not too scary, but really, you should be concerned. Gestational diabetes, should I be concerned? Yes, you should be concerned. As a woman, yes, you should, because you could run a risk. As a man, yes, you should, because you could have a wife or a sister or a daughter who could be at risk. Thank you, and do have a great day.
Thank you, Dr. Adele. I've learned so much about gestational diabetes, and I'm sure by now all of you are very much itching to ask Dr. Adele so many questions. Remember, the chat box is open, the comment boxes are open for you to send in your questions, which will be answered live. You get to meet our speakers live on Saturday and Sunday. So for now, next speaker we have is Dr. Abiola Fatima Adenowo, and she'll be talking to us about fighting free radicals with food.
Hello people, I am Dr. Abiola Fatima Adenowo, a researcher and lecturer at the Medical Biochemistry Department, Lagos State University College of Medicine, LASUCOM, Ikeja. And I am happy to be one of the speakers at the Soapbox Science November event. And I am here to present my research interest to you in a very simplified way that will make you be able to pick a few things from it for the benefit of your health and the health of your loved ones. Today, I am speaking on fighting free radicals with food. Looking at the topic has three main words. We have fighting, we have free radicals, and we have food. We are familiar with fighting, we know what that is. We are familiar with food. We all taking food. It makes us live. It nourishes our body and all that. Free radicals is the only word that could be a bit strange there. And that is the main focus of our discussion for today. Now, what are free radicals? Free radicals are atoms or substances that are present in the human body, and they get into the human body through various means. They are generated within the human body as a result of some metabolic activities, as a result of certain things that takes place in the human body, such as respiration. And the free radicals are mainly introduced into the body through the external environment. Examples of free radicals that examples of sources of free radicals from the external environment include pollutants from the environment as a result of industrialization and some other human activities that leads to generation of various types of pollutants. We can also get free radicals introduced into our body through the food we eat. Herbicides and pesticides that are used on the farm could introduce free radicals into our food crops. And once we ingest or take in such food crops, we will be getting some free radicals into our body in the process. You can also get free radicals from the sun. It can also be introduced into the body through smoking, through the consumption of alcohol, through stress, physical stress, emotional stress, and so many other external forces can introduce free radicals into the human body. Now, having explained what free radicals are, what do they do when they get into the body? Free radicals are substances that are deficient in energy. And when they are in the body, in that stage, in that state, in the deficient state, or in the state wherein they don't have enough energy, they are not stable. They are not stable and they are not happy, so to say. So for them to be happy, for them to be stable, they will need to take energy from surrounding cells. Our body is made up of different types of cells. So cells are going to be the victims of the free energy source of energy. Free radical source of energy. So the free radicals will take energy from the cells in their surrounding to make them happy and to make them stable. Now, we can liken the free radicals to robbers. You know what robbers does? We all know what robbers does. Once they want something they want to possess or they want to take away from their victims, they just come in. They just come, attack their victim, take whatever they want, and off they go. The same thing goes with the free radicals. Once they get into the human body, they will take the energy they need from the surrounding cells for them to be stable, for them to be happy. And in the process of doing that, they are causing great damage to the cells that are giving them or that they are taking the energy from. So that is what happens when free radicals take energy from the body cells. The body cells becomes weak, the body cells becomes damaged, and they become deficient in all ways. Now, free radicals, when they do this, they lead to various types of diseases which are very common amongst us, especially diseases that has to do with examples of such diseases include chronic diseases as a result of the accumulation of cholesterol. Bad cholesterol has some of the outcome of free radical action. They produce bad cholesterol which accumulates in the blood vessels, and when this takes place, it leads to various diseases including heart attack, including atherosclerosis, and so many other diseases. Other diseases that are associated with free radicals include diabetes, arthritis, damage to the skin. The skin is made up of what is known as collagen. It is a connective tissue that keeps the skin in a good form, that makes the skin elastic and be in a very good form, which everybody likes. But when the body is exposed to free radicals damage the collagen structure. They damage the collagen, they destroy the connective tissue, and then that leads to premature aging, which is very common around us now. You will see people of 20 years old looking like 40 and so on. So all these are as a result of premature aging that are occurring due to the effect of free radicals. Now, having said this, in as much as free radicals are being introduced into our body unwillingly, sometimes we have the opportunity to keep away from things that will introduce free radicals into our body. Sometimes we don't. Now, if you want to eat, you don't know whether the food you want to eat sometimes is contaminated or not. You have to go into the sun. You get exposed into the into the rays of the sun, and so on. So, how do we combat the effect of free radicals in our body? The negative effects of free radicals can be combated or can be overcome. We can fight free radicals that get introduced into our body through the food we eat. And that takes us to the word antioxidants. The only thing that can overcome the effect of free radicals is the intake of what is known as antioxidants. Antioxidants are those substances that will counteract or that will negate the effect of free radicals. When the body has substances known as antioxidants, instead of the free radicals taking away energy or electrons from our body cells, they will feed on the antioxidants, thereby making our body cells safe. So, in essence, free radicals are there, but then once you give the body enough antioxidants, then the effect of the free radicals will be overcome by the provision of substances that are within the free radicals substances within the antioxidants for the free radicals to feed on, thereby saving our body cells. Now, what are the various sources of antioxidants? You can get antioxidants from various foods that we take in. We can get antioxidants from green leafy vegetables. You can get antioxidants from cereals, from seafood, from fruits that we eat, and so on. There's a lot of sources that we can benefit from that can provide us with antioxidants. Now I want to lay emphasis on the provision of free radicals through vegetables and green fruits. We are so much gifted in this country, Nigeria, with a lot of fruits that we can benefit from to enhance our health, to overcome the effect of free radicals on our body. These fruits abound everywhere. We have common fruits, orange, mangoes, and so on. We have exotic fruits that can be a bit expensive for some of us, and we have wild fruits that are readily available from time to time during the year. So let us make maximum use of these fruits to enhance our health. Remember, you are what you eat. What you eat determines what your state of health will be. Thank you for listening, and I look forward to answering some questions from you during this question and answer forum. Thank you for listening once more. Bye-bye.
Wow, wow, wow. Fighting free radicals with food. Thank you so much, Dr. Adenowo. Our next speaker, Dr. Taufikat Abosede Adesalu, will be presenting on algae, nature's untapped protein resources.
Hello, everyone. Welcome to Soapbox November 2020. I'm Dr. Taufikat Abosede Adesalu, a botanist, and my area of specialization is phycology. What is phycology? It's just the study of algae. Phycology is the study of algae. What do you mean by algae? Algae are green plants. They are green plants, yes. Algae are green plants. And they can be microscopic or macroscopic. Okay, what's the difference between algae and those plants that we see around us? Algae are microscopic in nature, like I said, and can also be macroscopic. Look at this image. I'm sure you've noticed this, one of this, or all of this in your area. Those horrible looking green patches on the wall of the houses, the tiles on the bathroom, all the tiny corners where you have water dripping, those are the organisms called algae. Why are these algae disfiguring food images like this? You mean disfiguring? Okay. Because that place is wet and algae needs water to grow, they will always find their way. And these horrible looking organisms that we're talking about is what I want to discuss with you today, so that you see the other side of this horrible looking organism called algae. You must have witnessed one of these images around you, especially in the running gutter where you have all those green patches, slimy looking molds and all that. I'm still explaining where you can find this algae. But most of the time when you see these organisms, they are not really something that you want to look twice. When you see it once, you want to look all the time because they are not always nicely looking at. But as we are talking today, I want you to have another opinion about this group of plants called algae. Having said that, algae are green plants. They are green plants because they have chlorophyll. What is chlorophyll? Chlorophyll is that green pigment that assists in the process of photosynthesis. What is photosynthesis? Photosynthesis, in the simplest term, is just the way plants manufacture their food. You mean plants manufacture food? Yes. Plants produce food for other organisms to feed on, like you and I. How do they manufacture food? They manufacture food through the process of photosynthesis that I've mentioned. And during this process of photosynthesis, oxygen is being released. Oxygen? Yes. That air that you breathe in and breathe out, carbon dioxide. That carbon dioxide that you breathe out into the environment, if you have it in excess in the environment, we are likely going to be suffocated. So these horrible looking organisms does that work by picking up those carbon dioxide in the environment, use it up during the process of photosynthesis and produce oxygen for you and I, our process of breathing oxygen, breathe out carbon dioxide. Now, when you look at that organism under microscope, because I told you we have microscopic and macroscopic. The microscopic one under microscope, you will see this fine looking structure. I'm sure you like this image. I like it. But you won't see this until you use microscope. So can you see that these organisms are really, really good? Especially in that process of oxygen that you and I need. I will say that. Remember the Finding Nemo movie? Those small fishes in the ocean, they depend on these organisms for food because these organisms produce food. So in any environment you find these organisms, they are called producers. What are producers? Producers are those organisms that start the process of food chain. What is food chain? Food chain is just a line. Something will eat, another one will eat, and another one will. Let me explain. As human beings, we all love fish. Maybe not all of us, but some of us that like it. That fish from the ocean must have fed on these organisms. And we as human beings will take up that fish, we go to the market to get the fish, we prepare the fish and eat it. So from that microalgae to the fish to human being, that's just a simple food chain that we're talking about. Now, these organisms also, have you been to some of our beaches? Let me say it again. There are different types of beaches that we have. We have the sandy one and we have the rocky one. Either sandy or rocky, we have some of these organisms around that environment. And some of us even clear them around that environment to give us easy passage to enjoy our picnic and have fun. All those organisms that you are packing or you don't like are those ones that we're talking about because they are rich in protein. Having said that, we're saying that the organic food molecules from carbon dioxide and water through the process of photosynthesis in which they capture energy from. So now you remember that when you finish eating, the food gives us major energy. So when you take up a balanced diet, you are expected to have energy, and that energy is what you use to do any other things that needed to be done. Now, having said that, these organisms are also rich in antioxidants. during the time of COVID-19. Remember, we are asked to stay at home and boost our immunity. Now, I want to tell you something. This group of organisms are highly rich in antioxidants, and we can use them to boost our immunity. Not for COVID-19 or any viral infection. Now, we see the polyphenols, carotenoids. These horrible looking organisms that we're talking about. Now, I'm sure by now, there are no more horribly looking organisms to you because you know the added advantage. And you can turn it to wealth by any legitimate money for the process from the process of these organisms. Now, these organisms elsewhere in the world have been processed to different food supplements, and these are examples of those supplements that you can lay your hands on. Remember, we started from the horrible looking organisms and see the end product of that organism. I'm sure all of us like the package, the way these things are displayed. But if we start from the beginning, you realize where we started from. So algae are very important, and they have protein, and they can assist us in building our immunity and our well-being. Thank you.
Algae, algae, algae. Did you know that algae research was going on in Nigeria before you heard from Dr. Gestational? Remember to send in your questions. We'd really love to have them. Okay, our next speaker, I'm excited about this one, Miss Fatima Anwaju. Her title is The Role of Genes in Depression. Exciting. Please go ahead, Miss Anwaju. Enjoy the talk.
Hello, good day everyone. I am so excited to be here. My name is Amuju Fatima from Cell Biology and Genetics Department, University of Lagos, Akoka. My area of research is psychiatric genetics, which is a subfield of behavioral genetics in which we study the inheritance of mental disorder. In my research, I use bioinformatic tools, which are softwares that I use in the analysis of biological data. For my presentation, I'll be focusing on the roles of genes in depression. For different people, we have our different downtimes. We have when we feel sad. But in a couple of hours or couple of months or days, for the case, we snap out of it and we go back to our bubbly personalities. However, for some people, this feeling of sadness do not go away. It persists for a long period of time, for as long as years. Then depression might be suspected. Depression have different symptoms, and it includes perpetual states of sadness, feeling of hopelessness, feeling of worthlessness, tiredness, excessive sleep, lack of appetite, loss of interest in pleasurable activities, to mention but a few. There are two basic factors that have been involved to cause depression. These are the environmental factors and the genetic factors. In view of my research area, I will be focusing on the genetic basis of depression. I have used different bioinformatic tools in the analysis of depression, and I have found several genes that have been implicated in depression. Genes are units of inheritance. But I am narrowing down on only two, which are the COMT gene, the COMT gene, and the HTR2A genes. These genes have been implicated in the pathway of production of two body chemicals known as neurotransmitters. These neurotransmitters are the serotonin and the dopamine. They are produced in the brain, and they are also known as the happy chemicals. These happy chemicals are responsible for mood, body temperature, the feeling you get after you have engaged in a pleasurable activity is caused by the rush of dopamine. Sleep pattern, serotonin is involved. Control of mood, serotonin and dopamine are involved. But In some individuals, it has been observed that there are minor differences on these genes. These minor differences on these genes are called SNPs. They're pronounced SNPs, which means single nucleotide polymorphisms. And I've also been able to identify these single nucleotide polymorphisms using bioinformatic tools. After my bioinformatics analysis, identifying these SNPs, identifying these genes, then what do? I proceed into the laboratory. What do I do in the laboratory? First of all, identify my target people that I want to use for the analysis. After consent form have been taken and all ethical approval have been taken care of, I collect blood samples from these people and isolate DNA. That is deoxyribonucleic acid. They are the genetic materials of all living cells and tissues. I look for these genes and SNPs in this DNA material through a process called sequencing. After my sequencing of the different DNA materials of these people, there are lots of data that have been gathered. After the gathering of this biological data in laboratory, I use it in I use it for building algorithms for AI as a tool in prediction and diagnosis of depression. I don't do this alone. I do this with a colleague of mine in computer science to build artificial intelligence. Artificial intelligence is a process whereby machine mimics human thinking. I give a case of Siri for iPhone users. You can always ask Siri to perform a particular simple task, which it will do. Similar thing will be used in my own research using the molecular information, the biological information I get from my laboratory, building algorithms. Algorithms are set of instructions that carry out particular tasks to achieve a particular goal. In this case, the goal is to predict people that are at risk of susceptibility to depression and the objective diagnosis of depression. So using this biological data that I generated from the laboratory to develop algorithms for AI as a tool in the prediction and the objective diagnosis of depression is what I do for my research to improve mental health care all over the world. Thank you for listening. I am Amuju Fatima. Bye bye. Thank you.
The roles of genes in depression. Thank you very much, Ms. Amoju, for sharing that talk with us. Our last speaker for session 1 is Miss Elsie Chidebe. The title of her talk is How Drugs Work.
Hi everyone, my name is Elsie Chidebe. I work with Algae Pharmaceutical Limited and I'm here on Soapbox Science to talk to us about drugs and how they work. So basically, most of us have had to take medications for various reasons. It could be for headache, common cold, malaria, fever, or even more advanced situations. And in some cases, we've been told, oh, take this drug after eating or before eating, or don't take this drug together with that drug, or don't take this drug with this food or fruit and vegetable. And I'm sure you've had to wonder, oh, why is this so? Well, I'll tell you that here today. But first of all, what are drugs? Drugs are basically anything that when taken to the body brings about if so to speak change to the body. It could be taken via different routes, maybe through oral, as in the case of aspirin. It could be taken under the tongue, be taken under the skin, or directly on the skin, which is directly on the target surface. In some cases, it's taken via inhalation, as an inhaler in cases of asthma, or even directly to the blood, or even injected to the blood via a syringe. And in some cases, also taken via the rectum of the anus. And these various routes of administration are based on maybe the target sites, um, how quick this drug is needed, or um, or how the body might react to this drug if taken via other routes. But basically, what happens when you take a drug? So let's say aspirin, for instance. Aspirin is taken for pain. Now, what causes pain? When the body is injured, it's inflamed. So a certain chemical called prostaglandin um, would would be activated, and this causes inflammation. When this inflammation comes on, we are in pain. So basically, when you take aspirin, let's say you take aspirin orally, aspirin will be taken via the mouth and it goes down to the stomach where it dissolves. This dissolution is important because when the drug is dissolved, it would be easier for the drug to be absorbed and transported around the body. So when the drug is dissolved, aspirin is able to easily break down in oil and water. So this means it's also able to pass via the membrane of the stomach and the intestine. Once this is done, it goes to the liver, and in the liver it binds to the blood and gets to the bloodstream. Then, while in the bloodstream, it goes to identify target areas. So once it identifies these targets, it binds to it and stops the pain. Now, sometimes this could take an hour or up to 6 hours. But then for each drug taken, for instance, sometimes you're taking a drug and you're told to take this drug every 4, 5, 6 hours, or take this drug once a day. And this is because of the amount of time it would take for this drug to actually dissolve, be absorbed, break down, and then taken around the body to target sites. Now, these target sites are receptors, and these receptors work as a lock and key. So, for every receptor, there's a key. So, let's say in this case, so the key basically, so every receptor kind of has a key that would identify, that will be able to fit into the lock to bind to it and then prevent whatever that is happening, which would lead to the patient feeling better. As in the case of high blood pressure, this is actually how drugs for high blood pressure works. When taken, it goes down to the body and then it identifies the target, binds to it, and then prevents it from getting worse. In some cases, we might take a drug and would have side effects. You might take a certain drug and then you might be vomiting. On the label is, you might get a drug and it's written, oh, side effects might include vomiting or some skin reaction. Now, this is because of probably the drug isn't specific to that target, so you might be able to also bind to other targets, which might then lead to this side effect. Which is why it's important to always read your drug labels, to always talk to your doctor about if you have whatever side effects. He might actually prescribe something different for you because of these reactions. Now, it's also important to talk to your doctors because you might be taking a particular drug, and when taken together with another one, might lead to drug interaction. Now, this also means that due to this interaction, the drug might not work as effective as it should because the other one has probably reduced its potency. So this is why the doctor might tell you, oh, don't take this drug with that drug, which is a very, very important thing because then in the end, you might end up having to take a medication and there's really no change in your body, but mostly because of the interaction with the drug. Sometimes this happens with fruits, like for instance, grapefruit. Grapefruit sometimes, when taken with certain drugs, might lead to interactions. In some cases, even paracetamol, when paracetamol is taken with alcohol, it could also lead to little cases. It could lead to some of the side effects might even be as might even cause liver damage. Now, this is because alcohol and paracetamol actually do not go together in high doses, which is saying why it's good not to take alcohol actually with any drug, because a lot of the time it might react to low other drugs. So basically, always talk to your doctors for you taking a drug, read your labels. It's also important to talk to them because you might not know what specific dose to take. A dose might be good for this condition, and then you could be prescribed this exact same drug on a lower dose or a higher dose in an entirely different condition. So you might be like, oh, okay, I have this same drug, so I should take the same dosage because you didn't talk to the doctor. But in actual sense, you shouldn't. So always talk to your doctor to prevent side effects or low potency in drug. And remember, always read your labels. Always eat the right fruit before a particular drug as well. Thank you.
Wow, wow, wow. That brings us to the close of session one. Don't hurry off so quickly. We still have 6 other speakers in session two. The titles are so interesting. Please remember to send in your questions. Our speakers would love to answer them and interact with you. If you're on Facebook, if you're on Twitter, if you are on YouTube, type it into the comments box, send them in so we can answer them live on Saturday and Sunday, where you get to meet our speakers live and direct on all 3 of these platforms. I'd really like to say thank you so much to our first 6 speakers, Dr. Abdusalam, Dr. Adeleye, Dr. Adenawo, Dr. Adesalu, Miss Fatima Anwoju, and Miss Chidebe. So we hope to see you in the next session, session 2. Please share these videos all over with your network, those young people who are wondering what kind of research goes on in Nigeria. All of these are our top female Nigerian researchers doing exciting research in Nigeria. Okay, I hope to see you in the next session. Don't miss it. Thank you for watching.